Okay, ladies and gentlemen, I asked you to do this. What's y equals x look like?
Straight
Hopefully you did a straight line that goes to the origin. Okay. And then from last day I said, well, what did we do when we did the absolute value? Remember, for the absolute value, we took everything that was negative, and what did we do to it? So we took this part and we reflected it up. So notice the part to the right of the 0 stayed the same, but the part to the left of 0 now, instead of being down here, we reflected it to be up here because we're taking the absolute value. So anything that's negative becomes positive. Okay? So I hope those are the two graphs that you remember from last day. What I'd like you to do now is to look at the graphs and tell me, well, since the absolute value of x cannot be what? An absolute value of a number can never be negative. Okay. So what happened was that the part of the graph of y equals x that was below the x-axis, so I'm talking about this part right here, okay? The part of the graph that's below the x-axis, that's this part right here, is now what do I do when I take something on the bottom and put up on top? Reflected, thank you. Okay, reflected. Okay, reflected in the x-axis. And for this reflected part, can someone tell me the equation of this line? So now I'm saying, look at this reflected part here. What is the equation of this line? So think back from grade 10. Equation of a line. Any ideas? Remember y equals mx plus b? Remember this stuff from grade 10? First of all, what's b for this? The y-intercept. Good. So where's the y-intercept of this part I highlighted in green? 0. So I guess b is 0. Good. Now, what about m? What's m stand for? Slope. Right. So what's the slope of this downward sloping line going from left to right? Remember, rise, run, rise, run, rise, run. Seems like I'm not even rising. I'm going down. So I'm going down 1 unit for each one I go to the right. So that would be -1. So if you think about it, this equation is just y equals to -x. Okay? So what I want you to understand here is that, hey, that V-shaped graph actually has two parts. The part to the left of that 0 is the part in green, which is y equals to -x. And how would I describe this part over here in blue? Well, underneath I said the part of the graph which is y equals to x, that is on or above the x-axis, okay, where there was no change, is this part in blue. So I want you to also understand that this can be written as y equals to x. Okay? Why am I doing this for you? Because what I want you to understand later on, and we're going to do that right now, is that the absolute value of x can be written as two parts. Do you see the two parts that I've shown you here? Two parts, right? The one in the green and the one in the blue. And because they're written in two parts, we are going to introduce something called piecewise functions to you. And a piecewise function is this. It's something that's totally different. It's a function whose definition changes depending on where you are on the domain. Okay? Think of it as putting two pieces together to make one function. Okay? So what I'd like us to do is look at this picture here, and I want you to tell me what two pieces make up the absolute value of x. Okay? So what two pieces make up the absolute value of x? There's this piece in green, and there's this piece in blue. What's the equation of the piece in green?
Y
Equal to what?
domain.
No, y equals to what? -x. Good. That's the part in green. Okay? And then how about the part in blue? What's the equation for the part in blue?
Y is equal to x.
Y is equal to x. Good. So I want you to write that down, please. Where it says the piecewise function here. I want you to tell me that there's y equals to -x, and there's also y equals to +x. Okay, so two different pieces. Now there's still a little space here. So I need you to tell me, where is this true, or where is this valid? So can you suggest to me for the -x, which part is it? Well, it looks like to me that this is true for all these values that are to the left of the y-axis. How do we describe all these values here to the left of the y-axis? That would be, well, not quadrant 1, I'll say this. If what values of x? If x is less than 0. Can you see that the stuff in green only works for values of x that are less than 0? -0, -1, -2, -3. Okay. And then how about equivalently for the part in blue? What would the domain here? If, can someone help me out? X is what? What values of x? Greater than or equal to 0. Good. Okay. Now, notice what happens at 0. At 0, up there, and I'm sorry you can't see it right now, let me move back. The graph kind of changes its direction. Can you see that? Yes, Ryan?
For the negative x, is it also less than or equal to, or is it just less?
I've chosen to not put the equal sign there, just because I didn't want them to be on both. Okay? You can choose either or. You can put the equal sign here if you wish. Okay, like this. And then make this one greater. That's fine as well. But don't make them both. Because then the question is, when x equals to 0, which one do you use? Top one or the bottom one? I don't know. Okay? So I just like to make the one that's left or less, just less than. That's just my convention. Okay? Now, this point here, 0. You see where the graph changes direction? 0 here, right? At 0. I call it the breakpoint. That's just my terminology. And that's where the graph changes direction. If you read your textbook, this idea of breakpoint is given a different term. It's called the invariant point. Invariant means it doesn't change. I don't really like that term very much, but nonetheless, it is what it is. Okay? So what I want us to get comfortable with today is knowing how to draw these absolute value graphs and knowing how to write out this piecewise function stuff. Okay? So let's try a few examples together. All right? So example number 1 says define the following absolute value functions as piecewise functions, and if it helps, sketch out the equation without the absolute value first, and then go ahead and find the absolute value. So maybe I'll do that with you. Let's do some visuals first, and then from the visuals we'll find the piecewise function. Okay? I'm going to ask you to do this first. Let's just go ahead and sketch y equals to x minus 6. Okay? There's a grid there for you. So why don't you do it for me, please? See if you remember how to sketch out y equals x minus 6. Don't remember? What's the y-intercept for this equation? What is it?
0.
No, the y-intercept.
6.
-6, yeah. Good. And then what's the slope of this line? It's like a 1 in front. So what does that mean? 1 to the right, 1 up, 1 to the right, 1 up. So can you see how I'm creating this line? Okay. So I hope you can see that this is y equals to x minus 6. Okay. Now, tell me what happens, though, when I'm going to ask you to sketch out the function we really want, which is the absolute value of x minus 6. What is that going to be? So what do I do with the absolute value?
X is equal to 6.
Okay, so x equals 6 is here. That's the invariant point or the breakpoint, yeah. But what do we do with the absolute value stuff? Ryan, what are you going to say? Flip it up. Which part do I flip up? Do I flip up this part up here? More than 6? Do I flip this part that's less than 6? Less than 6. Good. Remember, everything that's negative gets flipped. So watch. This point used to be at 5, -1, and now becomes 5, 1. This point here used to be 4, -2, becomes 4, +2. 3, -3 becomes 3, +3, and so on and so forth. How about this point here? The y-intercept used to be at 0, -6. What's the new y-intercept for my absolute value graph? 0, 6 up here. Okay, so notice my absolute value graph looks like this now. Oops. Okay. All right. So the graph in red is the one I really am looking at for question A. Okay. And so we've graphed it out. That's great. Now, can you write it as the piecewise function? Okay. So let's see if you can now change this into a piecewise function. I'll say y equals, and I'll put a big curvy bracket. And now how many pieces do you think are part of this function? How many pieces? 1 piece, 2 pieces, 3 pieces? How many pieces?
3.
3 pieces? 2. Yeah, just 2. There's this one, and there's this one. Okay, so you are thinking about,
One down there.
well, that's not part of that graph. This one down there was just part of the original graph which we had to help us graph out the absolute value. Okay, I'm really just focused on the absolute value graph, which is the one in red, so I only have these 2 pieces. Okay, so now it's your task to find out the equation of the 2 pieces. Okay, and not just the equation, but also the domain where it exists. Shall we do the easy one first? Let's do the blue one. What's the equation of the blue line here? What's the equation of the blue line? I wrote it on there. Which one is it? That? Yeah. Yeah. So the blue part is just the equation y equals to x minus 6. So let's write down x minus 6. Now, when is this true? What is the domain for this part to be true? You said to me that it was bigger or equal to 6. So how do I describe that as my domain? If x is greater or equal to 6. No, I wrote this too big. So let me write it a little bit smaller. X minus 6 if x is greater or equal to 6. Okay? That equation and that domain represent the highlighted blue part of my absolute value graph.
Greater or equal to?
I use greater or equal to, yeah. Okay? Now, what about the part in green?
X plus 6.
X plus 6? Well, there is a plus 6 because your y-intercept is plus 6, but I don't think this is x. This is a downward sloping line, so how could it be x? Negative x, right. So now it became negative x plus 6, and this is true if x is less than 6. Good. Okay. Now let me just tell you quickly, all these absolute values of linear functions have 2 parts. One part that goes upwards, one part that goes downwards. And notice that one part, the equation stays the same, and the other part, what do you notice about how the green and the blue are a little bit different? The signs are different. So all you did was you actually multiplied by -1. Okay? So a key idea here is if you want to find out the other part, just multiply the original equation by -1. Okay? So let me ask you this now. Let's try part B. Okay, now for part B, can we not actually graph this out, or do you want me to graph it out with you? Graph it out?
That's scary.
Okay, let's graph it out. Scary.
Can you
Sure.
multiply by 2 in the bottom?
No, I wouldn't do that because you change the actual equation. Okay? You can only multiply by 2 when you're solving for x, because when you solve, it doesn't matter.
Yeah.
Okay? Now, how do we graph this one out? What's the y-intercept for this graph? 1. So let's start at 1. So I'll use purple. 1. What's the slope of this line? It's 1/2. What does that mean? When you go up 1, how many go to the right?
Half.
Well, not half. It's 2, right? Rise over run. Go up 1, to the right 2. Up 1, to the right 2. Up 1, to the right 2. So if you think about it, here are the points that you are creating, and I'm going to draw a line like this. Okay? So let me write this as y equals to 1/2 x plus 1. I hope you remember how to graph out lines from grade 10. Okay. Now think about what's next. I want you to not graph out that y equals to 1/2 x plus 1. I want you to graph out the absolute value. So remember, your goal is to sketch the absolute value of 1/2 x plus 1. How would you do that? Now, take the purple graph and what are you going to do to it?
Flip it.
Flip it. Do I flip? Which part do I flip? The negative part. So once again, take this part down here and flip it. So let's take a look at this point. This is -4 comma -1. It becomes 4 comma 1. -6 comma -2 becomes 6 comma 2. Negative 8 comma negative 3 becomes negative 8 positive 3. And now when you flip it, I hope you see a graph like this. Okay? So the one in black is the actual graph of the absolute value. Okay? Okay, so now where's this breakpoint? Where's the point where the graph changes direction? Yeah, if you can see, the breakpoint here is at negative 2. So I'm going to just quickly write down the breakpoint is x equals to negative 2. And now I'm going to ask you to rewrite this as a piecewise function. Once again, how many pieces do you think you're going to have? 2. Good. One of them will be this part in yellow, and the other one will be this part in purple. Okay, can you go ahead and try to find out what those 2 pieces are? Okay, I'll let you think about this right now. It's very similar to part A, so let's see if you can come up with an actual equation. I think for the one in purple, you should use the exact same thing. So I'll say 1/2, let me erase this. It's 1/2 x plus 1, okay? Same thing as the original without the absolute value signs. What values does this work? What's the domain for this part of the piecewise function? This seems to be true for what values of x? Greater than or equal to what?
Negative 1/2 x.
No, for what values of x along the domain? Where is it true? Where is this graph true?
Negative 2.
Yeah, bigger or equal to negative 2. So this is true if x is bigger or equal to negative 2. Okay? Now, all I've done so far, dear friends, is just write out the piecewise function representing this part that I highlighted in purple. What about the part in orange, or not orange, yellow, that got reflected? What do you think the equation with that of that part is going to be? Negative. So let's make everything negative. So instead of positive 1/2, let's make it negative 1/2 x. Instead of positive 1, what am I going to make it? Negative 1. Good. And this is true when x is less than negative 2. Okay. Now, can you write a little note down here? Okay. I'm going to say key point. Okay. The part of the graph that gets reflected. So the part of the graph that gets reflected has what type of change to the equation? The part of the graph that gets reflected, what happens to the equation?
All negative.
Yeah.
Multiplied by negative.
Yeah, it gets reflected. The part of the graph that gets reflected has its equation, okay, being multiplied by negative 1. Okay? So what I would like you to understand when you're writing these piecewise functions, and I know this is still weird for you guys right now, okay, is that the part that gets reflected, all you have to do is take the original equation and make all the pieces negative. Okay? The part that stays the same, when there's no reflection, well, guess what? The equation stays the same. Okay? Now, my last question to you is, how do we find this break point? How do we find this value when it kind of turns and changes direction? Notice that the break point for this one is negative 2, and the break point for the first one is 6. Where do you see those numbers, or where do you see that coming from?
Well, along the x-axis?
That's right. So the last thing I want you to find here, and key point number 2, is that the breakpoint occurs. The breakpoint occurs when, okay, when the graph crosses the x-axis. Okay. Now, let's just stop for a sec before we go on to the next page. Okay. I'm going to ask you to see if you can do this extra question for me. Okay. Sorry, are you still writing that down? Sorry. Okay. I want you to just in your head somewhere or just on a separate piece of paper really quickly. Yep. I want you to see if you can quickly tell me the piecewise function for this graph. Okay? Hello, sir. Yes. Here, I've got two more absolute value functions where I want you to rewrite them as piecewise functions. Let's do C and D together. Okay? If I were to look at the graphs and sketch this out, I'm going to ask you here, first of all, to please sketch out y equals to 5 minus x, and then we're going to sketch out the absolute value. Okay? So once again, we're doing this step by step so you see the process. By the way, once you get good at this, you don't need to sketch out things anymore. If you can just get the piecewise function right away, that's great. Okay? So let's sketch this out. What does 5 minus x look like? What's the y-intercept? It's 5. Because it's minus x, which way does the graph go? Up or down? Down. Slope, that's -1, so down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. We can do this forever, but we won't. Graph. Okay. Okay, now, dear friends, you go ahead and sketch out the absolute value for me. Take this graph in green and make the absolute value. So sketch it. Why does this one go down? Remember, this one, if the original equation is 5 minus x, that minus means that the slope is -1, so it goes down. This is different than the previous graphs where it went up, right? So, ladies and gentlemen, tell me, which part do I reflect now? Can you see that it's this stuff down here that I need to reflect? So if you were to reflect this properly, do you get a graph looking like this? Okay. And what's the break point here? Where does it change direction? 5. At 5. Good. So I'll write down here also the break point is 5. And if you wanted to find it algebraically without using your graph, just make the stuff inside the absolute value sign equal to 0 and solve. Good. I'm going to ask you to try now to tell me the two pieces of this piecewise function. I say there's one in yellow. I say there's one in green. You tell me the two parts and write them out with the proper domain. Good luck. Part of this graph stayed the same. Is it the yellow part that stayed the same or the green part that stayed the same?
Yellow part.
Yellow stayed the same. Now, when it stays the same, the equation is the same. So there's no change in the 5 minus x. So let's just make this 5 minus x. Good. See? Yay. Now, what is the domain for this part in the yellow? What values of x am I talking about? Are they less than 5 or bigger than 5? Less than 5. Good. So please write down, this is true if x is less than 5. Good. I mean what? Less than 5. Yellow part, less than 5. Okay. Now, the green part here seems to have a change. So when there is a change, what do we do with the equation?
Make it all negative.
Make it all negative. So instead of having positive 5, we'll make it negative 5. Instead of negative x, we'll make it positive x. Good. And this is true if x is greater or equal to 5. Congratulations. This is your piecewise function.
So all you do is just flip it around?
Exactly. The part that got flipped or reflected has a negative. That's it. But the key thing is you need to figure out which part does it belong to. Is it to the left or to the right? That's the tricky part. Because the previous examples have all been the part that does not change is to the right, but now the part that does not change is to the left. Okay? Okay, dear friends, you try to do D on your own. Okay, let's see if we can actually figure out the piecewise function without graphing it out. Okay, so let's see if we can do this without graphing out. Here's what I would do first. Can you find the breakpoint for me? How do you find the breakpoint?
Solve for x.
Solve for x. Make the stuff inside the bracket equal to 0. Solve for x. Let's do that.
Plus 4, so it's equal to -2.
So -2, x equals to +4, x equals to -2. Good. So the breakpoint, the point where the graph touches the x-axis, is -2. Good. But this time, I'm not asking you to graph it out, because I'm going to see if you can do this without graphing it out. This is the challenge. Okay. How many parts do you think you're going to have? How many parts?
As many parts as you want.
So how many do you want? None. Nice try. 2 parts, right? 2 parts. What do you notice about all these absolute value things? There's 2 parts. One part, the equation stays the same. The other part, the equation has this negative on it, right? So, let me just write out the 2 parts then. Stay the same, -2x minus 4. And then the other part is a reflection. So what do we do with the signs? We change them. What does it become? 2x plus 4. Good. So this one represents the reflected part. Okay. Now, here's the big dilemma. What's the domain for these parts? What's the domain? Okay, it's something to do with the breakpoint. So I will leave some space here, put a -2. Leave some space here, put a -2. And now the dilemma is, what sign goes in between? So what sign should be here, and what sign should be here? Think before you speak. For the one in blue, is it going to be less than or bigger than -2? Who says less than? 1, 2, 3. Who says 4? Okay. Who says greater than?
I'm going with you. What you doing?
No one. In this case, you're correct. It's less than for the blue part, where there was no change, greater than or equal to for the part that was changed. Once again, you may be thinking, why? Visualize with me what this graph looks like. Just put your pens down. Just visualize now, okay? Watch me is what I'm saying.
Same thing as that one.
Just watch me. -2x minus 4. What does the line look like? Well, y-intercepts -4 is -2, so the line looks like this, okay? Why is it going downwards? Because look, the value in front of the x is negative. That means the slope is going downwards. So therefore, what happens? We're going to change the stuff that was down here and reflect it up. So which part got changed? Was it before the breakpoint, so less than 2, or after the breakpoint, bigger than -2? After. So that's why the after part is the reflected part, and that's it. Okay? All right, more practice, dear friends. Number 2, I want you to graph out these absolute value functions. Okay? A is similar to what we just did. B is totally different. Okay, so let's do A. Okay, and there's a few more things here now. Find domain and range and rewrite the piecewise function. Okay, so once again, if you're not too sure how to start this off, may I suggest you do the following. I want you to sketch out y equals to 2x minus 6, and then afterwards, I want you to sketch out the absolute value. Okay, and then from there, let's see if you can answer the questions, domain and range, and find the piecewise function. Okay, please try this on your own. Okay. Here's what you should have sketched out. 2x minus 6 minus 6 go to x, something like this. Okay? And then when you do the absolute value, these get reflected. So I believe you get a V-shaped graph that's kind of narrow. Did we all get that, first of all? Uh-huh. Good. What's the domain for the graph in red? Oh, real numbers, right? The graph stretches from left to right. It goes across to everything to the right and everything to the left. All real numbers. What's the range in this case, though? What are the possible values of y?
Y must be greater than 0.
That's right. It's absolute value. There's no negative, so y must be greater or equal to 0. Nice. And the hardest part, what's the piecewise function? There are two pieces. There's a piece that gets reflected, negative 2x plus 6. There's a piece that stays the same, 2x plus 6. The breakpoint we find is 3. And the trickiest part here is what's the signs? So for the one in green, the sign should be what? Less than or greater than? Less than, right. This is the part that got reflected. It's less than. So the one should be greater than or equal to. Okay? All right. Let's do part B together. Okay? Yes. Oh, I'm sorry. It's not 2x plus 6. 2x minus 6. Thank you. I misread. Thank you, Danny. I'll give you a prize later. Okay? All right. Let's do the next one. Okay, ladies and gentlemen, what's inside the two absolute value signs in this case? It's a more scary function. It's not a line. Do you know what it is? Parabola. Right. So I'm going to ask you, first of all, step 1, sketch this. Then step 2, sketch the absolute value. And then let's take a look at piecewise functions and all that kind of stuff. Are you ready for some scariness?
Are you?
Nah, you don't need a graphing calculator, do you?
Yeah.
You do? Can I show you how to sketch this function really easily without a graphing calculator? Sure. Okay. Ladies and gentlemen, you know a parabola looks like a U-shaped graph, right? What's an important point on the parabola? The max-min point, good, the vertex. And what other points are kind of important? Where it crosses the intercepts, yes, okay? So what I'm going to ask you to do to help us graph out this first is to find these things. I like us to find the x-intercepts. And then I want you to also find what we call the vertex. No! Now this will be good review. I know you guys all like review, right?
I hate this.
So this is good. I planned it this way. Yes, pound me too back there. Okay. So how do we find the x-intercepts? Find the x-intercepts by, what do? Let y equal to 0 and solve for x. So let's do that. I hope you have space there. Okay. How do you solve for x like this? Factor. Right on. Can someone help me factor this? Two values that multiply to -8. Those same two values add to -2.
-4 and 2.
-4 and +2. Sure. So what does that mean for my x-intercepts? What are the values? X equals to 4 and x equals to -2. Oh yeah. So good. I'm always like, what's going on? Okay. So let's put some big points there. 4, 0, -2, 0. Good. Okay, now this part is new for you, I think. Maybe not, I'm not too sure. How could you now find the vertex? Okay, some of you are thinking, oh my goodness, Mr. Lee, I remember that we have to get it into vertex form. Vertex form, don't write this down. Vertex form is something that looks like this. Remember this kind of graph? Remember that? Vertex form, this is your P and your Q. That's your vertex. Remember how hard it was to get into this vertex form from a question that looks like this? Do you remember what we did to try to go from this form to that form? Something called completing the... Oh yeah. Remember how we spent like so much time on that stuff and you guys hated it?
I can't remember.
So, if I was nasty to you, I would make you do it this way. Am I nasty?
You have your moments.
Fine, Ryan, you do this. Okay? For those of you who think I'm nice, listen. Okay? There's another way of getting from here to here without completing the square.
Are you serious?
Yes, I'm serious.
So we use that on our...
Possibly you could have used it, but I just didn't tell you until now.
Wow.
Calm down. It does use the ideas that we learned before. And let's see if you can figure it out. Okay? So can you just put down your pencils and just watch right now? Okay? Relax and watch.
Relax.
Yeah. Hey, I have two x-intercepts, 4 and -2, right? And we know that if I draw a parabola, it will look something like this, right?
No.
Okay,
Can
we'll
it
go
go
back to
downward?
chapter 3. Oh, you're right. Good point. So Nasty says, it can go like this. Good question. So which one is it for our example right here? Don't know?
Yeah, you don't really know.
What do we have here? What did I ask you to graph
Oh,
out?
wait, it's positive because
It's positive. Right. So which one which one is it?
It's going upwards.
Going upwards. Yeah. So get rid of this one in blue.
Oh wait, how do we like calculate it?
Because the a value, the value in front of the x squared term is positive. By the way, this is the beauty of math, or the horror of math, where you need to know everything from before. Okay. Now, did you know something else about a parabola?
Or what, negative?
What about this point down here? Where do you think it is compared to -2 and 4? Where is it?
In the center.
In the center, in between, right. Why? Remember how we drew this line called the axis of symmetry? Remember the parabola is very symmetrical. It's a beautiful shape that to the left of the middle and to the right of the middle is the same. It's like a reflection. It's like a mirror image.
Yeah.
So if it's in the middle, what's the value of x then? If it's in the middle of 4 and -2, what's in the middle? 1. So you, Danny, and the rest of you said 1, just told me the x coordinate of your vertex. That's great. There's your p value. Okay, now how do you find the q value? How do you find the y value?
A squared plus b squared equals c squared.
A squared plus, no, don't just quote like random formulas like Pythagoras. Think about how you can find this. Now, didn't I tell you we had an equation for this graph? It was x squared, what was it? X squared minus 2x minus 8. Didn't I tell you the equation of this graph?
Oh yeah, e is equal times c squared.
So how do I actually figure out the y value if I know the x value?
You plug it in.
You plug it in. What value should I plug into this equation here to find the y value at x equals to 1? I just told you. 1. Right. So watch as I plug in 1. Let's do this together with me, dear friends. What's 1 squared? 1. 2 times 1 is? 2. What's 1 minus 2? -1. Minus 8 is? -9. Wow. There's your vertex
That's so hard.
without completing the square.
Completing the square's funny.
But notice, I can only do this if I have the x-intercepts. Okay? If you didn't do that first step of finding the x-intercepts, this method here, you can't, doesn't work. Okay? And you'd have to go back to completing the square. Now, let's go to your notes and let's write this down. Now, pick up your pen. So how do we find the vertex? Let me just tell you, the vertex is always in between, and please write this down now, in between the two x-intercepts. Okay? So what is the value in between the two x-intercepts? It would be taking the values of 4 and -2, adding them together, and in between means kind of like find the average. We'll divide by 2. So what's 4 plus -2 divided by 2? What's 4 plus -2? That's 2. 2 divided by 2 is 1. So this then becomes the x coordinate of your vertex. Okay? Please write this down. This is the quick way of doing things. If you like completing the square, go ahead and do that. That's the long way of doing things. You writing stuff down?
Not really. But I should.
Okay. Now, how do we find the y coordinate again? say plug in x equal to 1 to the equation y equals x squared minus 2x minus 8 to find y. Okay, and I will ask you to do that. 1 squared minus 2 times 1 times 8, that equals to negative 9. And I'll give you a chance to catch up with me, but the big thing I want you to plot here is 1 comma negative 9. Okay? I did all this because now you know what the graph of y equals to x squared minus 2x minus 8 looks like. It's this. Right? Okay. Sketch that in. And then now I'm going to ask you, let's actually do this question. What is the absolute value of x squared minus 2x minus 8 look like?
What?
Okay. All that work was just to graph out the parabola from before. Now I want you to do the absolute value of this parabola. So what happens?
Whoa.
Stuff that becomes negative, what happens to it?
Positive.
Becomes positive. Good. So watch.
That's weird.
This stuff here is positive, so I'm going to keep it the same. No change.
Now bounce
Right?
up.
This part over here is positive. Keep the same. No change. And then the stuff down here bounces up according to Tanasia. Okay? So let me ask you to tell me what happens at the point 1 comma negative 9. What does it become now?
1 comma 9.
1 comma positive 9. Right. Up here. And so your absolute value graph, which is the one in red, looks like this. W. Okay? So the graph in red is the absolute value. W. A U-shaped graph became a W-shaped graph. Get it?
Intriguing.
Okay. Now, before we finish, we still need domain, range, and piecewise function. Domain, really
All
quickly.
numbers.
All real numbers, yes. Range,
All the
quickly.
numbers.
No, it's not all real numbers. Greater, not just greater than 0. Yes, greater or equal to 0. Now, ladies and gentlemen, here's the hard part. What's the piecewise function? How many pieces do you think you have here?
Like 12.
12? Oh. 2?
4.
4? I would say 3. I would say this, okay? Just watch for a sec. I would say this becomes your first piece, this part. This becomes your second piece, the part that got reflected. And this becomes the third piece over here. Okay? 3 pieces. Here we go. So how do we write this piecewise function? There's 3 pieces. Y, and make a big squiggly bracket, please. Okay. Oh, by the way, where are my breakpoints for this graph here? 2 and 4? Are you sure 2? Negative 2. Good. Negative 2 and 4. So if I were to look at the different pieces, the yellow piece, the blue piece, and the green piece, what are the domains first of all? The yellow piece, the domain, this is true if x is what? Less than or bigger than? Bigger than negative 2? You have no idea. Let's look at the picture. Which part did I shade in? The values that are negative 2, negative 3, and so on to the left. So that means x should be less than negative 2. Okay? So what I'm saying to you is that this yellow part represents the part of the graph that is less than negative 2. Okay? Now tell me, what is the equation going to look like? So answer this question. Has there been a change in your equation? Has there been reflection? Yes or no?
No.
In this yellow part?
No.
No. So there's no reflection. You just keep it the same as what was originally written inside the absolute value sign. So this just becomes x squared minus 2x minus 8. Now, tell me about the part in the middle in blue. Was there a reflection, a change? Danny says yes. Lily says yes. The rest of you
Yes, yes.
say yes, 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 yes. Good. So when there's a change, what do we do with the equation? Reverse the signs. Awesome. Let's reverse the signs. Instead of positive x squared, it's now negative x squared. Instead of negative 2x, it's positive 2x. Instead of negative 8, it's positive 8. Bravo. Okay, that's the part in the middle. That's why I highlighted it in blue. Let me see if I make this smaller so you can see the all pieces. Okay, blue. In blue. Now, what's the domain for this part though? What values of x are true for the stuff in blue? Only the stuff in between negative 2 and?
X is greater than or equal to negative 2.
So it's bigger than negative 2 or less than equal to 5. So this is how I'm going to write this down. Negative 2 with a less than or equal to sign with an x and a less than sign with a 5. Okay, now you can put an equal sign there too. It doesn't matter. Oh, 4. Sorry, 4. Doesn't matter if you have an equal or not. Okay? This is the domain for the part in blue, which is the part that got reflected, and that's why I put a negative sign in front. Okay, the last piece, the one in green. Is there any reflections there for the part in green?
No.
No. So what equation should I use? Same thing as original. X squared minus 2x minus 8. Good. What's the domain for this part? X is greater than. I'm not going to put an equal sign now this time because look what I did. I put the equal sign on the blue one. Okay. Now if you want to, that's perfectly fine. Just don't have an equal sign on the blue one. There we go. Woo! Okay, ladies and gentlemen, let me assign you part of your homework, okay? Not all of it. So let's see.